Okay, so this is a quick review on scientific notation. So scientific notation is where you have a number, then a multiply sign, then a times 10, and then you have an exponent number up here. And if this exponent number is positive, that means that the number is larger than 1. If that exponent number is negative, that means that that number is smaller than 1. Be careful, when it's negative, it does not mean that the number is negative. It means that the number is less than 1. Here are a couple of examples of ones that you'll see in chemistry class a lot. 6.02 times 10 to the 23rd. So this is the exponent part right here, and it means it's way, 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 way bigger than 1. Here's another one, 6.2 times 10 to the negative 34th. Remember, that doesn't mean it's a negative number, it just means it's smaller than 1. So here's a little review on how to deal with it and move between scientific notation and standard notation. So here's one where we have a positive exponent and a number bigger than 1. So if we have 2.5 times 10 to the 2, then we would simply write 2 places bigger. So this would move 2 places over like this, and we'd end up with 250 or 250 because it moved 2 places to the right to make it a bigger number. So always look, if it's positive, it always means you're going to move it to a bigger space. Now if you haven't written this down in your notebook yet, write down yourselves, pause the video right now and write yourself a little note that positive exponent means bigger than 1. And if you have to write down means move to the right, go ahead and say that, but you should know that moving to the right means bigger. Now, if the exponent is smaller than 1, like a negative exponent, then that means that the number is going to end up being smaller than 1. So we have 7.8 times 10 to the negative 4th right here. That means that the decimal point is going to move 4 places to make the number smaller than 1. To make it smaller than 1, we would go 4 places this way. So 1, 2, 3, 4 places here, and then our decimal would go here. And we fill in zeros in each of these spots. So doing that once again, it'd be 7.8 times 10 to the negative 4th. 1, 2, 3, 4 places over, then our decimal point would go here. I always recommend putting a 0 in front of there too, so then you know that it's not just some smashed little piece of fly or something on there. And so then you fill in the zeros right here, and so then that means that it's 0.00078 as the number. One last rule. If you ever have a 0 exponent, remember anything to the 0 power is always 1. So if we have one like this, 7.2 times 10 to the 0, that's the same as 7.2 because this number is equal to 1. And 7.2 times 1, of course, is just 7.2. All right, here's a few more examples just to keep you going on scientific review, scientific notation review. You can write each of these down as we go. So this number is obviously larger than 1. And remember, the rule for scientific notation is to take and move the decimal so there's only one number in front of the decimal place. So 1, 2, 3, 4 places we'd have to move it. So it would be 4.2 times 10 to the number of places we move the decimal. So times 10 to the 4th. So that would be going from standard notation to scientific notation. Here's the opposite. Here's a number that is 1, 2, 3, 4 places until we get it to be one number in front of the decimal places, in front of the decimal place, and then you'll notice that this number right here is less than 1, so that means it's going to be a negative exponent, and it's negative to the number of places we move the decimal, 1, 2, 3, 4. So 3.24 times 10 to the negative 4th. What happens if you end up with people that break the rule? And we do that in science all the time. So here's more than one number in front of the decimal, 420 times 10 to the 4th. Well, since it's a positive exponent, that means we need to move the decimal, wherever it is, 4 places, in this case 4, to make it a bigger number, because it's a positive exponent. So we'd have 420, and then we'd move it 1, 2, 3, 4 places. So 1, 2, 3, 4 places, and the decimal would end up being right here. So 420, 1, 2, 3, 4 more. That would be our number once we go from this scientific notation to regular. How about this one? We already have a decimal right here, and then it says times 10 to the negative 2. So that means it's going to get smaller. It's going to get more or less than 1 than it already is. And so that means we need to move it 2 places this way. So then we end up with 0.00725. And then how about this one? This one's already a decimal, and then we get a positive exponent right here. Well, now we need to move the decimal so it gets closer to 1 if we can. Because right now we're way below 1 at 0.0038, and we need to move it 3 spaces to get closer. So 1, 2, 3, we end up with 0.38. I'm always a big fan of putting that 0 in front of the decimal place right here, getting a habit of that, because then it's easy to read the decimal numbers like this rather than a decimal and then some numbers. It's a quick review on scientific notation.